All right, here we go. So this is going to be round 2 of SSA training. I didn't actually put any slides together for this one, but I thought this would be more of taking a project that we're kind of working on and walking through a little bit more like what would it actually look like to take that CAD file and turn it into an SSA drawing and vice versa. Like basically use the stuff that we're already using, like Civil 3D, to turn that into something that we can use. So that's kind of what I'm going to do here. So the first thing I want to talk about, and we touched on this a little bit, was doing kind of importing and exporting. And this mouse might drive me crazy today. But basically in Civil 3D, what I have done is I have drawn in a bunch of, I'll isolate them here. I've drawn in all my on-site stormwater controls. Just have F1 on it. And then I drew in a few kind of off-site basins. And there are a couple different ways that you can basically import these into SSA. And I guess I'll just touch on the 3 main ones. I'm going to finish with the easiest one, which I think is probably the one to use. But the first one is called basically turning these into parcels, which I think is, for some reason, to me, really attractive. And it actually has to do with how you import things into SSA. So SSA, let me back up here and jump into SSA. I'm going to do a new file here. Under the import tab, you have the 2 that we're really going to look at right now are GIS import and LandXML import. Now, for those of you who do any GIS work, which is pretty much everyone, you're going to be familiar with this. This is like basically importing a shapefile, and it pulls data from that shapefile. The other option, which I think that one is probably the cleanest way to do it, the other option is the LandXML, which is typically how people import or export things out of CAD. So when someone talks about importing or exporting out of CAD, that's what they're typically talking about. So when I'm talking about exporting parcels or exporting catchments or any of these Civil 3D structures, I'm almost always using a LandXML file. Now, if you remember from last week, I basically clicked on a pipe network and right-clicked. Actually, instead of right-clicking, I clicked on this button up here, Edit and Storm Sanitary Analysis. Basically, what that is doing is it is creating an XML file. So it's doing that one that I told you is not very good. And then opening that XML file up in Storm Sanitary Analysis. The nice thing about the XML files is that you can pull multiple bunches of data together. It basically turns into like a text file, which is LandXML, which is pretty cool. So when I right-clicked on that, it shows you what you have that you're able to pull in from a pipe network standpoint. Alternatively, instead of doing that click on and export, I could also go up here to my output command and click on export to Civil, is that right? Export Civil 3D drawing. I think actually what I want to do is export to LandXML, which is sitting right up here. And that basically lets you pull any bit of data that is able to be written into a LandXML. So that's almost all Civil 3D objects. Surface, which can't be read by SSA, but the data would be in the file. Alignments, same thing. And then within these, you can see actually I've put in some of these land use basins. So I'm going to show you real quick. I'm going to unselect all of these. I'm going to click a couple of land use basins I've already made. So I'm going to click on these 2 just to kind of show you maybe a couple over here as well, just to show you what would happen. So I'm going to call this land use XML example. And so you might be wondering where is that data located? And let me actually turn on all my data. So you can see I have a bunch of different stuff in this drawing. This is basically the TAC drawing, TIR file that I made. So I have some basins drawn in as polylines, some basins drawn in as what are called parcels. So they look like regular pieces of information, but they're actually Civil 3D files. So for example, this is a parcel block. And basically what I did is I just basically drew in a random polyline. And then, within this information, you can, create parcel from objects. And so that basically is able to pull surface data from it. It's able to, it creates, I guess, additional data, which can then be pulled into an XML. So that's the real benefit of a parcel data. I'm going to go into SSA here and show you what it actually, how you actually pull it in.
Plus, Paul, doesn't it have some geographic sense? Like if you change a boundary on a parcel that's adjacent to another parcel, it maintains single borders and things like that.
Totally.
As well as the Civil 3D intelligence.
Yeah, they're really you're right. It does all that stuff. Really what they're meant for is for like land divisions, like land, they're called parcels, which kind of gives you a little sense of what they're supposed to be used for. So I drew it in, and this is data that I've drawn in from XML, from, in Civil 3D. So it's pretty cool. It pops right in. It draws the area, which I think is really valuable. And so the thing to know, though, is that once I've brought in an XML, I can't bring any other XML file on top of it. Like you can basically only bring in one LandXML for each drawing. So, for example, if I would have gone back to my drawing here and I would have outputted, say I was a little bit smarter this time, and I decided, okay, well, I need more than just my land use area. I need to have my pipe networks as well. So let me bring in, I'm going to bring in, a couple of different parcels, as well as, these two, I'll just bring in one pipe network. I'll call this with pipes. So I can bring them all in together, which is kind of cool. But again, oh, shoot, I forgot something. I can't just go back and import it. So there's kind of good and bad of it. The really good thing about these parcels is it brings in the area. It looks like an area. Now, the second option I'm going to talk to you about is you'd think would be the one that would make the most sense to use. Because this is, I think, when people made this information, I'm having a hard time opening up. When people made this specific Civil 3D element in CAD, I believe this is what their goal was, are called catchments. Now, catchments are part of basically the analysis tools within Civil 3D, and you can see all these little flow paths that I've already drawn in here. These are super cool, like some of the flow path type of analysis that you can do within Civil 3D. So I can click on a water drop. I'm going to tell it which surface I want to use, and I basically click a point and it tells me where it's going to flow, which is pretty darn cool, especially for our proposed areas. They're super accurate, because we have really a really good defined surface. So these are really helpful for figuring out where water is going. But also within this, you can select create a catchment area. And so I'm going to create a catchment area from a surface. And basically what this is going to do, that didn't work. So at the discharge point, this is kind of hit or miss. So I wouldn't, theoretically it's awesome, but sometimes it doesn't work so great. Click on this point here. I can create a catchment, which basically is, a basin boundary. It automatically generates it from the surface. And not only that, but I can actually link it to a specific structure. Let's see if that worked. And it didn't actually work. And it has to do with the surface. Sometimes you have to find the really good spot.
It was asking for the discharge point still, wasn't it?
Let me try it again and see. But Ken's probably better at using these than I am, to be honest.
Actually, this is fairly new, so as far as Civil 3D goes.
This should work. See, special location is not on the selected X.
Mm.
It's kind of spotty. I've had some kind of mixed results with it. Let me just try something over.
It looks like it's confusing the structure with the surface, so when you're trying to link it, so I don't know. You try it without doing the structure linkage and just
Yeah, okay.
throws it.
I can do that. It's a good idea. It still doesn't work. Again, I've just had a lot of well, for whatever reason, it's not working at this current second. But another way you could bring that in, actually. So I guess the point is, theoretically, it is possible to bring it in and connect it to a structure. And then, actually, I don't know if you remember this from last week, but once it is connected to a certain structure, you can then click on this again, do your edit and storm sanitary analysis. And when you bring it into SSA, it will already be connected to the right structure, which is pretty cool. However, when you do that, it does not draw it in as a shape. It just draws it in as like a point. So you end up with, here, actually, I drew a catchment over here. Let's see if I can connect this specific one to a structure. Catchment properties. So once I'm in here, let's see if I can connect this one. To a structure. Okay, so say for example, this may or may not work. Let's see what happens. It looks like it's only bringing in the pipe network, but it should actually bring in that catchment connected to. And that didn't work. Something came in. So what it did here, and I don't even remember this, but it actually brought in the background, it brought in my CAD file. So I'm going to unload that just so it's a little bit easier to see. And then it brought in all those pipe structures on the same network. And then it brought in this parcel of this catchment right here linking to that thing, which is pretty darn cool. If you have all of them linking to the right things, it's really kind of powerful. But again, I really like having it show the shapes. So I don't like this method for that very reason. And you'd think that Autodesk would solve that, but for whatever reason, it's not something that they've updated yet. So anyways, those are the two ways you can bring them in, basically as using a LandXML file. Now the third way, which I think is the best way and what I would recommend using, is to bring them in as basically just do them as polylines. And unfortunately, they only work as polylines. You can't draw a catchment and bring them in this way, and you can't draw like a feature line and bring them in this way, which for some reason doesn't make sense, but whatever. So the command is map export, and I showed this to you guys last week. So this should be nothing new. Actually, it's a little bit easier if I isolate this layer first. This basically allows you to export as a shapefile. Tac demo. So again, you have to come in and click a couple options here. So click polygon. We're going to select manually. And there's one other thing you have to make sure you check. It's this treat closed polylines as polygons, because we're actually going to be doing polygons. So we have to tell the computer that what we're picking is polylines. And then I'm just going to come in here and select all of these. And then it's going to want to know what data to send with it. So we can click on this, and I usually just click on all for properties. If you wanted to, you could click on, I could actually just bring in area if I wanted to and block name and call it good. So I guess we want to do that and see what happens. I haven't tried that yet. And then click OK. And if you have a bunch of different ones, like say I'm bringing in first my offsite area, then my onsite area, you can save a profile and kind of have it all set up the way you want it to be, which is a pretty cool tool. And like I mentioned before, this is not like a LandXML. So you can import it one time and then import more stuff later and then import more stuff later. So now we're going to go over here. And this time, instead of the LandXML import, we're going to do our GIS import. Go to my subbasins. This is the one we just did. So right now it's asking, okay, where should I pull the data from? Now you'll notice that a lot of these are empty. So, what if I wanted to have these be a certain name? So I have to manually change them from within SSA. Or my curve number data, it'd be really cool if I had the curve number data in here, because then I wouldn't have to import it in. So I'll get to this a little bit later, but having more data go into your model to start with is definitely better. SSA is not the easiest thing or fastest thing to manipulate things, to manipulate your data. So I'll show you later how this is important, but just note that it's pulling data from a source, and right now the only source it has is that those CAD polylines. So here we go. It all came in, which again, this is really snazzy. All the shapes come in. But as I mentioned before, actually I should change a couple of the project options here. So right now it's set as EPA swim, but if I come in here and change it to Santa Barbara, SRCS or SCS method for my time of concentration. My weighted curve number right now is, for some reason, and I'm not totally sure why it does this, but I think it defaults to a 25% impervious area. And so, in reality, what I want this to be, probably 100%, because this is all roadway. So what I have to do is I have to come in here, copy these over. Again, this is doesn't take that long, but it's something that if you're constantly importing stuff over, you have to redo every time. So it's something that it's not, I guess my point is it's not a super dynamically linked method like you would have with CAD, like what you'd theoretically have with another type of program, which I'm not sure if that exists out there or not.
Well, so one thing to look at on that, Paul, while you're checking, HydroCAD, they've done a pretty good direct link to AutoCAD now. I don't know if that might be a tool that we could use to get to this step where we're dynamically updating in CAD, running it out so that all the land use is added to it, and then somehow put it back out so we can pull it into SSA. It might be a extra step, but something that provides a dynamic link that's tied to the hydrology.
Yeah, I think I don't know of that tool, but
I just know that they continually update with AutoCAD, whereas SSA, ironically, is still fairly new to Civil 3D.
Totally. So. One thing that I found and I'll get into this in a second, is that this is like a shapefile, so you can actually add this data into your shapefile, and then when you pull it into SSA, it can be used. And again, this is all pretty straightforward, because we have, this is all a roadway right now. So we're going to have time of concentration of 5 for pretty much all of this, and a curve number of 98 for all of this. But when you're getting into like bigger basin models and stuff like that, that's when you're actually having to kind of calculate that information. So that's when you really would, and especially if you're going into this information and changing these values, that's when I think you'd really notice a difference if it was some dynamic link in there. So anyways, that is a way to bring in the data. Actually, I haven't tried this before, but I'm wondering what would happen if I brought in a LandXML afterwards. So I don't think I can bring it in. I think you have to bring first your pipes in as a LandXML, and then you got to bring your basins in afterwards.
There's not a setting to append to.
There is an ability to do that, but I guess I don't know. I've heard of this thing, but I have not been able to find it. So if there's a way to do that, then I
haven't tried it either.
So another thing, you said that you like to have the shapes in the background.
Yeah.
So I guess I'm just trying to track and follow. So would it be helpful if you just had the shapes as your CAD drawing in the background and then you could import it once? Would that meet that need?
Again, like I don't think my way is the only way to do it. If there's another way that you want to do it, that's great. And yeah, if you're fine with those little points, then yeah, by all means, kind of do it the way you like it.
Yeah.
Use a layer from your drawing.
Because like originally, I think it was showing up as the CAD file.
Yeah, you can bring it in the background if you go to that import.
Yeah.
You can basically.
I'm just not sure if that saves solves other problems, or is it just another way of doing the same thing?
It's definitely going to be a hybrid of something.
Yeah.
Because I don't think anybody has a clean solution all the way through.
Okay.
The nice thing about having the shapes is, let me bring this drawing in the background here. One thing I should mention that I just found out today, when you bring in these drawings in the background, it doesn't necessarily allow people to use them at the same time. So we might need to copy them out, another thing that could be a potential issue. Rod was telling me he couldn't get into this drawing earlier, and I unloaded it, and then I had to actually get out of this drawing
We had to close it down.
to use it. So
Yeah, we definitely don't want to tie the drawings
definitely
in that
not.
way. Who's SSA Paul?
Another thing to note is that it does not pull in XREF layers. So, I just dropped my line work. I just dropped the line work file in, but it can't pull other XREF layers. So if we were going to make a file that we wanted to use, we could do like what is that command? There's a way to bring all your XREF into the actual file. Bound or bind, is that it? Yeah.
Yeah, so I mean, if you have a catchment file in CAD, I think what maybe to Jeff's point, you wanted to use the method where you're bringing in just the point data for the connectivity and then background it with just a line work file for catchment. That might be a way to
Totally.
But,
I think for me, the visual of it is really helpful. And there's also one other cool feature of it, and that is, it's basically, it has an area in here, but this area is not just, a point. If I come in here and I edit coordinates, or I guess how do you edit? I think there's edit vertices as the option. There we go. So if I bring this in here, it'll actually
update the area.
And that actually probably is the same area before, but if I right click on it and go to recompute area, it now gives me a different area. So that's one cool feature of it.
Yeah.
But again, we're probably not going to be doing that. We're probably going to be doing my preference for myself is probably to do most of that work in AutoCAD.
Or you have a surface.
Yeah, exactly. So again, that's a cool thing you can do, but do you need to do it? Not necessarily.
Let me ask you this, Paul. I don't know if you've investigated it or not, but traditional old time-consuming element of the hydrology is finding out the land use and the curve number. So is there anything in GIS, like proposed land use and existing impervious or anything like that, that we could bring in that would help us with that tedious step?
Figuring out the quantities, the percentage
Well,
of impervious.
say you've got a subdivision. Say you've got a pasture right now, and it's going to be an industrial development, so 85% impervious. So it's shown somewhere in the county's GIS that this is going to be industrial development. So there's curve numbers associated with that.
Yeah.
So that's the future condition, but also I think in GIS we've got some existing impervious information. information.
Clean Water has
Can we
that
bring
layer.
that in?
Clean Water has that layer, but I don't know that it's sufficient for
It's
what
not
we
good
would
enough.
need. Yeah.
I think you might be doing those calcs separately. And I think, yeah, again, within these land use areas, I mean, really where you notice the difference is, if you have a generalized curve number, or if you have, this percent imperviousness, you could play around with that value as well. But that's really just telling you, what curve number to use.
So at this point, anyway, the GIS information is really good enough to contemplate doing that. We've got to develop it ourselves.
It's good enough for planning level, but it doesn't, where we're more interested in what's connected impervious. I don't think it provides you with a good way to.
If you were doing a large amount and, you really didn't want to do it a certain way, when you import the data, you could theoretically do this within, a shapefile or GIS. You could calculate, I guess this average slope isn't going to really change anything, but you could have it tell you what the impervious area percentage is from that layer from Clean Water.
Oh, but that layer's not that great. So it's not accurate.
I don't know. I'm not sure. It seems to be relatively accurate from what I've seen, but
it's not gonna have any split between like what's a roof or what's a driveway or what's a road in a subdivision versus a roof. And I think it's a little dangerous to think it reflects what we're trying to capture.
I think you're right from a planning level.
Take that out of the picture then for what we're going to do in the near future. We're not going to try that.
So what I had always done as a workflow was go into the GIS and say I had a subdivision. I would just put down, I would call it all impervious, say, and just blanket it with one polygon.
Yeah.
And then cut out, just trace over the stuff pretty quickly in the aerial and cut out for existing condition and then just give it a value in the database table. So that it's all mapped as, roof, lawn, road, the land use elements. And then you can dump that into CAD pretty quickly, or you can bring it straight into here, but you still don't have this dynamic link that we're talking about. And I'm not sure. The only way to get the dynamic link, I think you can use the mapping function of AutoCAD to actually hit the database in the back end. But I don't think that ties all the way forward into SSA either. So it would help you on the CAD side, but not on the modeling side.
Yeah, I think in one way or another, you're going to have to draw in wherever impervious. You can draw it in CAD. You can draw it in GIS. This is actually a drawing that Ken did, so I figured I'd bring it up to show you.
That I'm sure I did that in the GIS.
Yeah. So yeah, if you want to draw within GIS, you can use the edit tools and do it that way. And there's nothing wrong with doing it that way.
But you do need to draw it. There's no such thing as just
you can't push a
putting
button.
a base in and say what's the curve number in here or whatever. Can't do that.
Doesn't exist that I know
of. Some of the cool things about doing what we did with those shape files, exporting from CAD with those shape files, is you can. I'm actually bring it in here. I think it was. So I'm used to two screens here. You can just drop them all in right here and then edit them as you want to. Like I was mentioning before, this is a shapefile, so it has attribute data in it, which is somehow impossible to see. See if I can drag it over. And so if you want to come in here and actually, I could come in here, I could add a field, call this curve number. Come in here and edit this feature. And it should be all the way to the right. And I can basically make this, I can turn these into whatever I want, you know? And I know for a fact they're all 98, and I guess is there a way to edit them all?
You can, yeah, field calc it.
Just say,
Just put 98 in the box.
so then if I go to my editor again and save edits, and now I'll just show you right now what would happen. If I'll go, I think it was this on-site one. So I believe I have a curve number value in here now. There it is.
Yeah.
And so it'll just pull in that curve number value. So I mean, there are ways that we can track this stuff pretty well. But again, it's not dynamic. There's kind of an I wouldn't even call it iterative. I would just call it like a linear path of how you do that.
And the only other thing I know of that could help with that is getting back to what HydroCAD has for their catchment nodes. Well, if you have the land use in there, it can calculate curve number for you and give you a weighted curve number. And I know there's a link between it and AutoCAD. I just haven't used it. So
Okay. From what I've seen from AutoCAD, there was they had some sort of connection with some specific company. But maybe there's more that I don't know about.
from HydroCAD.
Yeah. Yeah.
I just know that whenever I do the installs, they update the AutoCAD link regularly. So I know it's looking for the software, and there is that ability to link the catchments in there. So
Okay. It's good to know. So after you bring in this data, and actually I'm going to start over because I realized I need to actually bring in that XML first. So I'm going to bring in a LandXML file, and this is where I have land use example with pipes. So this is one we just did, tack on site. I might even just go back. Right click here. So yeah, this is a linear process that I would use. I've just brought in basically a ton of pipe data. You can see some of these are kind of going off in the middle of nowhere. And the reason is some of these are, for some reason or other, I think some of these are outfalls compared to these junction nodes. And I guess I can mention that again, what that is, but let me unload this first. So there's a few things you kind of have to do to clean up this file to make it usable. And basically what I would do is first I'll just bring these in real quick. The ones that I just, so just tack offsite. And I'll also bring in my offsite values that I had in here. Okay, so I brought all that data in. So I know that I have all this data in here, but they're not actually linked up together. I mean, some of this gets a little bit tedious. You kind of have to delete a bunch of information from here. And what I found is that it brings in some extra outfalls. And basically an outfall in SSA is something you have, we could have one of them on your project. You don't really need to have more than one as far as I know. So I know my outfall is right here. So I don't want all these other outfalls. So what I'm going to do, I'm going to come in here, and whenever I see an outfall, I'm going to convert it to a junction. Just kind of one thing you have to kind of do.
Is there a way to select all, like basically you know the one that you want to keep, but select all the outfalls, switch them to junctions, then go back and just switch that one back to an outfall?
There's not, at least as far as I know. This is, I would say, one of the more tedious things about this program is that, like, for example, say I'm in my junction node and I want to, maybe this is a bad example. Say I'm in a pipe node and I want to turn all these, I want to turn all these to 0, all these entrance losses. Or, my Manning's roughness, I want to turn that all to 0.13. Like, I can't do that. There's no way to do that. There's no way to select all of them. The only way that I have figured out a kind of expediting the process is you can make a little Excel table, or actually 0.13. You can copy this, and then I come in here.
It's so funny, the workarounds. Like, that's exactly what I used to do in swim.
But it's like, why can't you do this? So I mean, this is one of the issues with this program is that it's really not, you have to do a bunch of stuff to set up this model, whereas it should be, it should be relatively seamless. And unfortunately, it's not.
Can I ask you a question?
Yeah.
Why? Well, maybe this is a better question for off the recorder, but we can talk about it later.
Why do we do stormwater design at all?
No, the question is, but we should just table it for now. It's like, why do you think it should be better than it is?
Okay.
So it's just something to consider.
Totally. So anyways, I see these random links going all the way over here. So that's, I guess one of the many things we're going to have to do to set up our model. Right now, I'm just going to actually just delete these links. So anyways, you kind of end up going through and doing some of this kind of random stuff that you feel like is sort of a waste of time. And then separately, all these subbations need to be linked to a specific node. So I need to connect this to here. This needs to be connected to here, which that is one of the cool things about the catchments is that they're already linked to them. So if you could theoretically link all those in AutoCAD if you wanted to. Another thing you have to do, and this is a little odd thing about my specific drawing. Actually, I'm gonna open up the actual pipes drawing here and show you. But I have a bunch of old, they aren't even that old, 5 or 6 year old manholes and structures that are already in the road that I would like to keep. However, we're raising the road elevation several feet in places.
Just looked at it.
So what we're going to do is we're going to basically just pull off the top cone and possibly top riser section and put a new one on. So we're not going to replace the whole thing. However, in Civil 3D, there is no way to do that effectively. So we're kind of doing some more workarounds to make it look right in the drawing. However, I have multiple pipe networks on top of each other that aren't actually connected, which you would think, does that really matter? Well, it does matter when you're trying to import it into SSA. And so when this opens up, I'll show you here. So you can see the green is the existing pipe network. And I'll actually turn on my line work layer just to show you what the roadway section looks like. So you can see we're repaving everything north of here, and this road section is coming up quite a bit. So there's an existing structure right here that I want to keep. I don't want to have to dig the whole thing out and put a new one in. But what I did in Civil 3D is I put one pipe network on top, and then underneath this pipe network, and I'm going to just send this to the back so you can see what it looks like. I guess you can actually probably see it even there. There's an existing pipe network on top of it. However, when I import those drawings into SSA, it gets really confused. It doesn't know what to think. So I think that's right here. Maybe it's not right there. Maybe it's up. Actually, this one might not have even worked out. There you can see like that. There's some of these structures that aren't actually connected properly. So you have to do some of that cleanup as well. I would not say every drawing is like that, but you end up doing stuff like that. So what I kind of come in here and do is I, kind of have Civil 3D open one side of the screen and the other one on the other side of the screen. And actually, I don't have these layers turned on, but you can come in and turn your node IDs on so you can kind of see what their names are a little bit easier.
Is it the same network, different network?
So in Civil 3D, they're on different pipe networks.
Yeah.
But in this drawing, there's only one network.
And when you say export to SSA, does it give you the option to say only this network, or does it just?
It does, yeah. So you could I could only bring in one of the networks if I wanted to.
Yeah.
But in this case, see, I have this green network here. If I decide, well, these ones are overlapping some of my proposed network, I don't want to bring it in, then I'd have to come through and redraw those in somehow in SSA. So I guess I've determined that I would rather delete some extra data rather than import, superfluous data. So that's one other thing you have to do. And then you also end up finding out where certain pipes may or may not, for whatever reason, have imported correctly. And I don't totally know why this is. But I found out when I was doing this model, a few of the pipes, for whatever reason, were coming in the wrong direction. And I think the reason that is because within Civil 3D, each of these pipes actually has a direction built in associated with it. So I guess I don't know what that little dialog is. There's the command QP mode. I think it is. Oh, it's already on. I don't know where it went. It's probably off my screen here. Anyways, moral of the story is they have a start and an end node. I think you can actually hover. Endpoint, start point. So you might not have realized that this is important, but when you're doing stuff in SSA, it becomes important because it imports a certain direction. I'm trying to think what else.
Well, it's important with your Civil 3D pipe network too, because it won't label the slope correctly.
Yeah.
And your start and end inverts. Yeah.
Okay. So I guess you have to make that work anyways. I'm trying to think if there's anything else. The last thing you have to really do is just set up your model. And I'm going to do this one more time just so you guys can remember. You will not be surprised that this model is not going to run because I have a bunch of cleanup work to do. I'm going to open it up after it's already been cleaned up. But again, just a reminder, what you need to do to run your model. We typically run SBUH. You can also run SRT55 if you want to run it that way. And then you set your time of concentration method to TR55. Now you just set this to 5. I pretty much always think this hydrodynamic works better. If you just have a single span of pipes, you don't really need to worry about it. But if you have any sort of flow coming in from different directions, some sort of pond, you really want to run hydrodynamic. You also need to come into your analysis options, and I usually set this one, go to the start time and start it from yesterday. So you have 24 hours, and this should be 1 day here. And then we will have to come back in here and after we add our storm event and select which type of storm to use. I'm going to put a rain gauge in here, and I'm going to click on this little button right here, which basically tells me to build a rain gauge. I don't know why they have so many clicks required for this thing, but you have to click it so many times. Again, we're all right. Washington, it already gives you Clark County, which is nice. This is something you got to look up in our stormwater manual, but it's going to be probably around this 3 to 3.2. Make sure this is type 1A, 24 hour. You can put different storm events if you want to in. This is a good starting spot. Let's click OK. click close, and click close. And then go back into my analysis options. And I'm going to click, instead of this use assign rain gauge, I'm going to click use this for the whole project. Actually, I probably should have labeled this rain gauge. It's a little bit hard to remember if you have multiple ones going on. I'm going to call this 10-year. So now it should show up as 10-year. So if we have multiple storm events. Alternatively, you could go into each one of these basins and select the rain gauge for that. However, that would take forever. So don't recommend spending the time. So that's basically what you need to do to come in here and set this model up. It can take a little bit of time. And as you can see, if you make some big changes to your model and you want to re-import stuff, it can take a lot of time as well. I'm going to cross my fingers that this other one works correctly. I believe this is the right one. I'm not sure why I gave you that error. It's a little bit scary. You're getting an error in your model.
This is your cleaned up one.
This is my cleaned up one, yeah. I don't know if it's loading or it's giving me a little bit of problems. It's probably just the mouse. So you can see I've connected all these networks in here. And actually what I did was I drew a storm pond in right here, which, let me actually turn on that background file so you can see. So there's a storm pond right in this area. And basically what I did is I put in one of these storage nodes. I basically converted one of the little manholes that I had in my pond to a storage node. And when I went in here, I went into my storage curve value, and I clicked on this button right here. And I basically just took values from my storm pond. So I have a little elevation pond data that I pulled out from AutoCAD, and I imported that manually into SSA. So now I have this information in here. And then separately, I added in a couple of extra links. I kind of have my pond overflow, which is just a conveyance link, just a pipe, like an 18-inch pipe that runs, assuming this has a high flow discharge. And I also added in these little guys, an Orifice and a Weir. And the way you can add these in, they're just kind of like links. You can actually draw them a little bit off to the side, which I found is actually really helpful for seeing them clearly. But I have my Orifice in here, which I got this information basically straight out of WIM. So
On the auto thing or something.
yeah, I calculated it in WIM and clicked on my pond, gave me that value at a certain elevation, and then I basically put it in the same way. I set my elevation right here, 171.25. It's my invert elevation. I have a diameter of this, which I got from WIM. Again, the point of this, I guess I was talking to John about this a little bit. I've been trying to think of there's kind of like two things that we're trying to do here. We're trying to save the fish and save the streams. And that's kind of what we use WIM for, size the pond, size all these things to build them in a way that's not going to have a negative influence on our environment. Separately, we also want to check to make sure we're not going to flood anybody or create a hazard on our road, or create some catastrophic damage to someone or something. And that's kind of what we use this other program for. And that's kind of how we think about stormwater design. Like, one is for like environmental design, make the environment better. The other is for trying to protect our houses and our life. And that's like pipes, inlets, overflow structures, 100-year flow path, all that stuff is for protecting our infrastructure and people. These huge ponds, they're not protecting, we used to call them for flood control, but in reality, they're really to protect the fish. So I think of we're putting this information in from WIM, but really what I'm trying to see is what happens if a big storm event occurs? Is it going to flood someone? Is it going to back up my system? Are there issues that I need to worry about? So I'm putting these in here, but in reality, I'm not really that concerned about them. They're not going to tell me, oh, my pond's too small, my pond's too big. What they're going to tell me is when a big storm event occurs, or this structure's plugged, or where are the weak links in my system? If that makes any sense.
What you'll be able to tell there is where we were a few years ago, where the wish was to go into existing detention ponds and rework them to save the fish in the stream and such.
Totally.
And what we needed to do, and what we did do, was run the old drainage single event model through them. And it showed it was backing way up in the pipe upstream. So
Exactly.
that was tedious, but it's quick with this method.
Yeah, this is quick. And I mean, I was saying how annoying it was earlier, but I did all this in like an hour or two. So it's not really that bad.
And that gets to my question that I kind of want to take offline. There's a couple things going on when we build a model like this. I would argue that if you do a change now to your basins or your overall design, or a pipe, it's pretty easily updated in this model now that you've got it situated, and you don't need to use that export function or import function to support it. And yet you still have this pretty robust model to look at. And the other thing that I'm not as worried about some of the import goofiness, because it's our responsibility as the engineers to really understand the model that we've created and to have it, this idea that it's going to come over clean and be perfectly, and then we just run it. That's really dangerous compared to having to go through and make sure we understand what
You're
we've
trusting
created.
it too much.
Trusting it too much, yeah.
So in a sense, you almost want it to be not perfect, but like enough of a pain that you have to check everything, but not so much of a pain that it's really
it's discipline,
efficient.
right? Like if it was perfect, I would argue we still have to have the discipline to go through it and make sure that it's representing the infrastructure correctly. So,
Totally.
And the last thing I would say to that is it's come a long way, and so I know that you youngsters may feel a little bit entitled to a software program that does all this stuff, but you've got it pretty good. So know what you're building and make use of it. So
That's a good point you made, though, because the old, way back to hand calcs or the first Excel spreadsheets, you had numerous points at which you could check and correct your input. You could scan a table here. You could scan your curve numbers, for instance. 103, where did that come from? So you had several checkpoints, and you just had to do them manually. So you always saw them. And there's a benefit to that, although it's a whole lot more work. So we've got to find ways to check this stuff.
yeah, and I think the tools, even though there's some clunkiness to the importing and then restoring the model or getting it set up initially, it cuts out a lot of the tedious stuff that we would have to go through and then not have time to do the checking where it mattered the most. And I think we're really in pretty good shape. I think it's pretty cool to see this in Swim as opposed to HydroCAD and doing pond
Totally.
nodes and a dynamic run. So
Yeah.
I think it provides us a view of the hydraulic grade line that's much
It's
more
pretty
realistic.
cool.
So yeah.
So anyways, this model should run. I had it running this morning. Make sure it,
It's perfect.
for whatever reason, random little things. So it was saying it wasn't assigned a rain gauge. But in reality, I just need to use this guy. I don't know why I did that.
So Paul, just to say, so I was looking at your TAC thing earlier. Is TAC now in this model, and that's what you're using from here forward? Or you still got to do that? You're still going to do that?
Is TAC
I mean,
done?
you're choosing TAC as an example, but I was just looking at the TAC plans. Your intention is to bring TAC into this, to complete what you've been demonstrating today. Or is that already done?
TAC is 50% plans are done. So I would say we're close enough
There's
along
the time to start
that I
this
think
in earnest.
at least this is a good time to check some of this stuff, especially areas that I'm a little bit concerned about. I mean, look, I know that where I set my pond is, I wish I could have set it lower than I did, but
Yeah, 'cause I
we're
was
kind of
looking,
constrained.
the pond looks different than I remember, so I think it is time to check it.
And for whatever reason, this is giving me a headache. I'm actually going to open up a different file. So what it's giving me an error, and the error it's giving me is with these curve numbers. For whatever reason, when these ones got brought in, you can see it's kind of like it's giving me like two different percentages. 25% of my area, it's saying is curve number 0.08. And 75 is 0.2, which doesn't make any sense,
No.
of course. So what I would do here is I would come in, set this at 198. And again, you could do this relatively quick. I think there's like 30 basins. But I'd delete this and then just copy that over, 100% and 98. So you kind of have to do that for each one of these. But I did have this working. Let me see if this other one is working better. Oh, man. All right, well, I might take a couple minutes to do this. I'm sorry about this, guys. It was working.
When all else fails, blame IT. You're not recording still, are you?
I'm still recording. It's officially, we have an official stance. Let me see if I change these analysis options to SP. All right, it worked. I don't know. I wonder if those curve numbers are still really low. I'm kind of curious what's going to happen.
Would you do just switch it to different method?
When you switch the method, it changes how they get brought in. Like, I don't know if you noticed, but they use a third tab when I do the other method. Okay. So that actually might be part of the import issue. If you're playing around with the imports and you're having some annoying things happen, I think actually it may make sense to start a new file and then set your methodology first before you import. So something to play around with. I haven't played around with it too much. But anyways, you see, this is red right here is telling me that there is a backup in the system. So I'm actually going to come in here and show you what it looks like. So you can kind of see what's going on here. I'll turn on the Output animation. So water's starting to come in the system a little bit.
Yeah, bridges.
And there goes the manhole lid.
Yeah.
So you start to maybe wonder, okay, what's going on here? 176.44, it's so much lower. Probably what this is a structure. I think this is a structure within my pond. So it's right. Let me bring that data back in. I'm wondering if that. Try that again. Yeah, so you can see that this is sitting, right in my pond. I'll turn this one on here.
That's your over.
That's that
control
structure right
overflow,
there.
man.
So this elevation is way higher than that. So I think, yeah, it might appear terrible, but I don't think that's actually going to
That
be
actually
killer.
That would overflow in that case, wouldn't it?
Yeah, I would think so. So maybe we're going to have to put a bolted lid on this one. That's what we're going to learn from this.
Well, is that your beehive or is that your?
That is
Oh, no,
just
it's
a
not.
structure.
So that's going to go up to the low point in the road.
But you can see manhole A2 is the one that I'd be really concerned with, which is this one, which it is going up to this point.
Yeah.
Anyways, this is the whole purpose of this thing, is to show you where your weak points are. Maybe we need to lower that pond a little bit more. Maybe we need to upsize some pipes or set this. This structure right here is really setting. If I bring this down to 175, which I don't think I can actually do because it'll interfere with the pond elevation. But that's going to lower, and then I could rerun this.
You're making me a wee bit nervous because I've just been looking at your pond.
And there you go. Now it's a little bit better. But anyways, the whole point of this is, I should say, this is not a finished model, but just something to set up and show you guys what it can do. But yeah, the whole point of this is, like, this type of information is super valuable for our models, and it's not an analysis that we typically do. So it's, it provides better designs, basically. So the last,
You could actually be. It could be that giant hypothetical storm is actually a worse condition for the storm sewer than any wind counts.
it's true. Also, I don't think I even have
It
my.
usually is, I think, isn't it?
No, I don't think
Single
so.
event.
No, I think it can accommodate it as long as your pipes have got capacity. I think that the pond doesn't rise as much with a single event. So you might have more flow coming in, but it's for a shorter time.
I thought you were
And
talking about
the
your
pond-
back-to-backs, not.
No,
standard
not the
single event.
back-to-backs. Yeah.
This also, I didn't put any sort of overflow. I really should put in, like a weir or a
Yeah.
structure that goes
Yeah.
over to this point.
You should.
So,
but
there's
it
more
shouldn't
to-
be triggered.
There's more modeling that needs to be done here. The last thing I wanted to show you guys was a little bit of inlet design. I'm less bearish. I'm less worried about inlet design than I was before I spent a little bit more time on it. It is a little bit tedious, but it really is not as bad as I had said it was. So basically, the way I have a few inlets in here right now, but the way you can put structures in. You either put them in as junctions, which is just like a manhole, or you can put them in as inlets. And the second you put them in as inlets, it kind of gives you a lot more options of what you can do with that structure. And now you're actually trying to figure out, do I have capacity in that inlet to catch water? If water is all the water going to go in the inlet? If not, where is it going to go? So there's basically two conditions for an inlet. And this is, I guess I'll show you what this is. This is kind of our standard, 3 structure low point. And I think it is right here.
You're only calculating one.
Well, we actually can put all 3 in there. So we have like our biggest, beefiest one in the middle. And these ones are they're really backup options, if you will. Worst case scenario, water is backing up in the road, or this gets plugged or fails in some way. Does water have another way to go? And in reality, if a pipe gets plugged, we're kind of stuck. There isn't redundancy there, but there is redundancy with these backup manholes. And this is kind of a typical design. This is kind of what WashDOT recommends doing. So this is a big reason we do it. It's just a good way to have extra redundancy in the system in case something does go awry. So this one is going to be what's called on a sag condition. And so this really is a big difference maker in terms of how you actually get this model to run. So inlets are semi-frustrating. If you set every single inlet to a sag condition, then your model will run. It's never an issue. It's when you set them on grade that you have to kind of set it up a little bit differently. So on grade just means water can go past this, but in the event it does go past it, what happens? Where does it go? And how you basically make the model run with that system, how you solve for that is you add in another link here. And so I'm going to set this right here.
Link for the gutter.
Including my gutter link. And I'm drawing it way back here, but I'm mostly just doing it so I can see it. I'm going to right click on this and convert this to inlets. Same with this one. So this one I'm going to set to on sag. And you can see the structure here. This is a combination inlet, which is what we install everywhere. But we typically design all of our inlets just to have the grate opening. So if you're trying to be super conservative, you can do it this way. We have not discussed what we're going to do going forward, but WashDOT does not have a methodology in their hydraulic manual for designing combination inlets. So we've just been designing overly conservative. Anyways, regardless, something to discuss later. This does give you the option of doing both. And then a few things to set up this value, and I think I still haven't open. I think our standard WashDOT inlet is 2 feet by 24 inches by 20 inches. So we make this a little bit smaller. You can adjust your clogging factor. All these stuff is in the WashDOT manual. I have to kind of look it up to see what it needs to be. I can't quite remember. This roadway cross slope is almost always 0.2%. This is usually 0.016. This gutter slope is 0.02 here. And then this gutter width, we actually have it as 1 foot. And then gutter depression, I think this should be 0.02, but I saw John Davis using 1 inch in his. So I don't.
What's the units on that one?
Inches. I believe, I'm not totally sure what the answer to this one is. It wouldn't be 0.02. It might be half an inch or maybe a quarter inch.
Yeah, is that on the,
or it might be
on the
1
frame
inch.
itself?
Yeah, if you look at our detail,
See the detail.
see if I have one open.
Depends on which detail. I think it's 1 inch.
Yeah.
you can see right here, there's this, not depressed curb. There's this little 1-inch thing right here, but I don't really know what that is for. That looks like it's calling out this piece.
Look at the
It's a
inlet.
drainage weak.
Look at the inlet detail with the apron on it. Looks a lot like your picture in, or like a gutter pan.
Concrete curb inlet, this one? Or the concrete, the gutter pan one?
Sorry, my eyes are still not quite back.
Gutter.
No, it's not. I don't think that's what it's called. It's
Approach or something like that.
yeah, I saw it in here. What is it under?
it's going to be under. It's under the drainage details. The D's. It might be that concrete curb inlet. I'm not sure.
Not
What-
that one.
Yeah, go back into that. Is there a note on there? That's not quite the one I'm thinking, but
Anyways, it's the information is out there. So this value can be looked up. It might be 1 inch. That's my guess, but I'm not 100%
I think
sure.
it's an inch.
This data is already put in here for you, which is kind of nice. Anyways, this is pretty cool. This information will be put in when we run the model. And then this one right here is where you kind of need to dial this in a little bit. So I'm going to set this to combination again. It was 24 by 20. Is that right?
Is
So-
that your flanker or the sag one? Sorry.
This is the flanker. So this is the bypass link.
Yeah, so the flanker's not usually a combo though.
You're right. It should be a smaller structure. We should use that washed-out combo.
Well, yeah, that's true. We have been using those. But you
So I'm
can
gonna
use
close
that
it.
at the sag point too. I think that's ops preference from what I understand now.
So like the big one can.
Can't actually read what this says, but I'm just going to call this W3. I think this
They
is.
don't have to deal with the lid and
Yeah,
try to get.
that's an ugly structure.
So if you wanted to be the most accurate possible for this bypass, you really should come in here, set it as open channel, come in here to user defined, and then you could build your own cross section with the roadway. I decided that I think just trying to send it as directly as possible. No, don't try to model it moving along the sidewalk. Just send it directly there. However, for whatever reason, the model doesn't like this, the direct. So what I was using was just rectangular, and I just set my length to 1 foot, and then I set my, so it's really steep, 20%. No losses in here, and then where is it in here? I saw Manning's value. I just set this to 0.01. So basically, it's instantly getting there. It's moving extremely fast. It's kind of another workaround. So now I built in my bypass area, and when I have to make sure I select this, I'm going to select this as my bypass link, and this will only allow you to pick stuff coming out of that structure. So you could either have it be your pipe or your bypass. So this should work. Let's cross our fingers. Looks like it ran.
What does that bypass look like in construction?
It's just
the
water that goes, say you have a lot of water running to your inlet, and it only captures 80%. 20% of it needs to go along the curb.
So it's continuing along the curve.
Continuing
it's not
along the
watering
curb.
out. Okay.
Exactly. So for this example, let's see what happened. 88% efficiency, so that means 12% of it's going past. And you might think, okay, that's not that much. But if you have, 15% from that one, 15% from that one, it keeps kind of adding up. So if you have a long run of inlets, it can matter. But the gutter spread is pretty darn low here. These values are a lot lower than I'm used to seeing on our spreadsheet. So I think there's still some work to be done to see how these compare with what we end up getting in the washdot spreadsheet.
You're probably able to take more water because you have it set as a combo up there too.
Definitely.
Yeah.
You're definitely right. There's one other thing that I think I need to do. Actually, this value needs to be put in for these grades. So this is going to be your longitudinal slope for your road. So basically, what is your road? Not the cross slope, the down water flowing into your inlet. So that, I think in this case, it's pretty steep. It's like, I don't know, 5 or 6%. But you actually need to go through and put these in and check in CAD what they are. So that'll affect your inlets as well. But honestly, I think this is a pretty snazzy tool to be able to do this inlet calc within Autodesk. And then you generate a table.
Is that the report?
I just generate a table. These are for all the inlets. And again, it's pretty cool. Like, it pulled the data from CAD, so now it's going to tell you all the information linked to those same IDs.
So that's a nice table.
But you can do that for any of your nodes. If you either double click on here and click on report, you can just right click on any of these types, and this will just basically pull all your pipe data.
What does it give you for a report for like a grade line?
I haven't really played around with it. There is a create custom report option in here. I think you can basically do all that same stuff, put that in a PDF. And then, you probably could also drop in, all of that, those charts. You could probably drop something like this in here. I'm sure you could drop other information in as well. So I haven't played around with that very much, but that's basically all I had. Hopefully that shows you what it might look like to set up a project using this program. I was talking with John about this a little bit, and I think personally, I honestly, it doesn't matter to me what program everyone's using here or likes to use. I think whatever everyone does themselves is great. I would love for people to, take charge of the programs that they want to use, and you want to build your own Excel spreadsheets, great. If you think this program, there's more to learn about it and you want to figure that out, that's great too. If you want to keep using HydroCAD, I'm not going to say no. But I don't know, I think everyone at least should know what the options and tools are and determine what they like the best and what's easiest for them to use.
Yeah, I think this is really helpful, Paul, so that we can all see what the capabilities are. And I can tell you my preference for our group would be that we all use a similar tool, only because it helps us work the bugs out and be collaborative on it. If there's something that you're really wedded to that you've used for a long time, I don't have a problem with that either. But I think the swim engine provides us with a lot of things we haven't been doing in the past, and it really will help us out in some scenarios. And I even think that there's a case to be made for doing the Inlet Calcs this way. I've done enough of those washdot spreadsheets, and it's just tedious. It's prone to error. You get one number wrong, it looks like you've got a good bypass value, and you would never know. In here, it's a little more bulletproof if you have it set up right. So anyway, so my preference would be that we head this way as a group, unless somebody's really adamant against it, and with the caveat that there's still some checking to do with some of that import function. You and I can talk more about that.
I like the power, the swim part, the power of the hydraulics. And, theoretically, there's so many jobs I remember in the past where I should have or wanted to do a hydraulic grade line and just blew it off and made a quick assumption.
Now the whole county's flooding as a result.
It's better. No, because I'm sorry. But you would want to do it for completeness sake. And I mean, it's a very useful thing. Like, so you design for 10 years. So we made an agreement, the county with the developer, say, we made an agreement, we're only going to make you pay for a 10-year pipe. Well, from my engineering standpoint, that's fine in a lot of subdivisions, but at some low points in the county, I'd really want to see what happens in a 100-year storm. And this does it. Nothing else really does.
What's also interesting that we design, I mean, a lot of it has to do with our local hydrology, but they don't require HDL lines to be calculated.
No, I think you do trigger it with sometimes. I mean, I think we've asked for them in the past. I mean, I also worked in development engineering.
I'm not
for a
sure
while.
if they still do. But
We
ask-
did in the past, if we saw a bad spot, we would ask for a hydraulic grade line.
Yeah.
But maybe not anymore. But we really want to know. I mean, we're not doing just the subdivision design. We're at the receiving end of all their subdivision designs. We really want to know what happens in a big storm. So I really like that, the power of it. And there's jobs like Thomas Wetland, there's no way to do it without this.
Yeah.
It's just not. You can't analyze that without it. So there is the rare occasion with a very flat drainage where you really need the hydraulic capabilities. And for those, we'll just have to use this. That's what John used on Thomas Wetland. So we're stuck with it for that, whether we like it or not.
Well, as far as the consistency, I think it does help us to when we're doing our own peer review of designs to have something that we're consistently using.
I would,
And it's not that bad of a learning curve. It's a bit steep. It's got a lot of pieces to it, as you've seen, but you guys are all quite capable of wading in and figuring it out and asking the right questions to get there. So
I would agree that I like the looks of it. And I mean, I've got to learn to check it too. And I think it would be good to settle in. We've got one good program now, Civil 3D, after going through Eagle Point and God knows what else, that all stunk. We've got one solid program now. It's a good one. And this looks to me like there's been all kinds of software, hydraulics over the years. It's like finally we've got one that is pretty good. We could stick with. So yeah, but I think a good check would be to run it on a project, and it's got to report out the stuff that allows it to be checked, and it's got to report out the stuff that the TIR asks for. So find a way. That looks like a pretty good setup right there. Find a way to export enough information and get it in a TIR that allows it to be checked, because there's an awful lot of computer manipulation going on. And you always have to have a system that will see if all this output makes any sense at all, because it could be gibberish. So we've got to work a little bit on printing it out, but that looks very promising right there. That is your output.
Yeah, I think there's some really cool things about it. But again, it can crash. It is a little bit of a learning curve. It's going to take some time for us to get ramped up on it.
The one thing that's really pretty useful, apart from being cool, is that running the storm and showing the simulation. That looks to me like a pretty good debugging thing. You could apply that, say, to your control structure. See if that control structure is making any sense. And you'll just see it rising up and say, "Oops, oh shoot, I forgot this." Go ahead and change it.
Could even actually, I haven't tried this yet, but I kind of wonder, is this it? Time series plots. I think it was, yeah, what's this one?
I had a thought maybe for your consideration, Ken, is we just got through, or Stephanie just got through her East 2 project. So we've done all that the old-fashioned painstaking way, got our results. It would be a good exercise, I think, for Stephanie to learn this, to just replicate it in this. You think that would be worthwhile?
Yes, and not a priority right now.
Oh, that would be the learning mechanism we might try.
Yeah, no, I don't think that that's a bad thing to go back to. And our priority right now needs to be our documenting what's come before, and catching up all of our projects.
Yeah, it's just tempting,
on
it's sitting
TIR.
there and it's a way of checking and debugging
I
right
get
away.
it, and I think that's a good way to learn it, and it's not a priority right now to go back and duplicate until after we've documented where we're at. We need to cover a lot of that just so that we're caught up, and then move forward.
I don't know what I'm doing here, but
I guess I would
trying to
say
see
one
what
thing.
data I can get out for the pond. I don't know.
Well,
There's
you still
definitely
don't have
data
your
there.
Overflow splitter set on the pond, do you?
I just have like an Orifice and a Weir. I don't think I know if I.
Oh, did
showed
you add
this.
the Weir just now? Sorry.
No, I have like one of these is an Orifice,
Yeah.
and then one of these is a Weir. I basically just stole the data from. Again,
Okay.
I stole it from Wim, so I have both of them in there.
So
That's your little notch basically in your pond. So these are the low flow values, and then this is basically a high flow, like an overflow essentially.
Do you have to change your, is it called routing method, or your calculations when you put in some kind of structure like that? I ran into that when I was trying to do some flow splitters and stuff like that for the Lightner landfill.
You definitely need to like this. Make sure this is on hydrodynamic for sure.
Okay.
Another thing that if you're doing any infiltration, you got to make sure you mess around with this thing. And there's a bunch of different ways to do infiltration in here. But yeah, if you have this set to like these two, kinematic wave is supposed to work for like multiple pipes going into stuff, but when you have like a pond or any backflow, it's supposed to need to do hydrodynamic. But I've even found
What exactly is hydrodynamic? What is? I know what kinematic wave theory is. Hydrodynamic. What exactly is that?
I think it's like I was talking about that kind of advanced hydraulic modeling where it's doing like a mass, like a volume balance and a momentum balance. So it can, it can go forward or back.
What is it called?
The St. Venant
Equation.
equation.
Equations.
It explains it. I mean, I'm assuming it would be the SWIN.
Yeah.
You can look up their manual.
And that's a good point. Is there a handy manual? You just click on help and there's a good manual.
It's pretty
explaining the
good.
theory,
I mean,
or is it just like the user manual?
it's got a bit of each in it. And it's pretty good, I would say.
Okay, so you'll find answers to most right in that thing.
I
Yeah.
used it quite a bit when I was struggling through the Lightner landfill. Trying to
And you
remember
found it pretty good?
Yeah.
Okay.
Just do a word search and get to the part you need to.
Best way to
Gotta know
find
the
stuff
word,
for
yeah.
sure. So yeah, I encourage you all to play around with this program as you
I
have
guess
time.
I would like it if maybe we just did do our Inlet Calcs with it as well, and everything was in one program. I mean, I know there's value